Hey there, chemistry students. So we have talked about in our unit here about chemical reactions. We've talked about chemical equations, and we've talked about how to balance chemical equations. And now we're going to talk a little bit about some different types of chemical reactions. Right. So our target that we want to work on here is to be able to describe different types of chemical reactions. And we're going to talk about 5 different kinds of chemical reactions here. All right, the first type of reaction we're going to talk about here is what's called a synthesis reaction. A synthesis reaction is probably the simplest one. In a synthesis reaction, if you look at the reactants, you'll see 2 elements, and they join together, and you see in the products a compound that's composed of those 2 elements, right? So a synthesis means joining together. So in a synthesis reaction, you have 2 very simple elements, 2 things that you'll find on the periodic table, join together and make a compound. You can see a picture that's an example of a synthesis reaction. Now this one is kind of general. It doesn't have real elements in it. It just says A and B. A and B in the picture represent 2 different elements. And you can see they join together to make AB, which is a compound composed of 2 different elements. And that is a synthesis reaction. The second kind is called the decomposition reaction. And the decomposition reaction is pretty much exactly the opposite of the synthesis reaction. Synthesis was 2 things coming together. Decomposition is 1 thing breaking apart, right? So in a decomposition reaction, you'll see 1 thing on the reactant side, and it'll break apart into 2 or more things on the product side. So you have a compound that's fairly complex, breaks into simpler things on the product side. And that's a decomposition reaction. You can see in the picture there, AB reacts to form A and B. So it's pretty much just exactly the opposite of a synthesis reaction. Rather than coming together, it's breaking apart. Okay, the single replacement reaction. It's a pretty simple one. In a single replacement reaction, what happens is that 1 element replaces another element in a compound. So that's why it's called single replacement. It's 1 element replaces another element. So in a single replacement reaction, you'll see on the reactant side of the equation, you'll see an element and a compound. And on the product side, that element that was by itself will take the place of one of the elements in the compound, and then that element will be by itself on the product side. So in a single replacement reaction, you'll see both an element and a compound on both sides of the equation. So it's pretty easy to tell that it's a single replacement if you see an element and a compound in the reactants, and you see an element and a compound in the products. If you take a look at the picture, you can see it's AB and C react to form A and BC. So what happened is 1 element replaces the other in the compound, and then that element gets booted out and it's by itself now. That's the single replacement reaction. The single replacement, by the way, is also sometimes called a single displacement reaction, depending on who you're talking to. Some people say single replacement, some people say single displacement. It means the same thing. And along the same lines, the next type of reaction is called a double replacement, and sometimes people call it a double displacement as well. So double replacement or double displacement, same thing. In a double replacement reaction, I like to say everybody switches partners. Okay, so in a double replacement reaction, you've got on the product side 2 different compounds, and what'll happen is those compounds will just all switch their atoms. So then on the product side, you also have 2 different compounds, but each element has a different partner now, right? That's the double replacement reaction. If you check out the picture of the double replacement reaction here, you can see it says that AB and CD react to form AD and BC, right? So everybody switched partners there. So A was originally paired with B, and now on the other side, on the product side, it's paired with D. If you look, C was originally paired with D, and on the product side, it's paired with B. So everybody in that reaction has switched partners, right? And that's the double replacement reaction. Okay, the last kind is called a combustion reaction. Okay, and a combustion reaction, maybe you've heard the word combustion before, you're familiar with it. Combustion basically means burning, right? And in a combustion reaction, I mean, that's what a combustion reaction is. It's something burning. And what happens in a combustion reaction is you have some very specific elements in the reaction, okay? In a combustion reaction, you'll have something plus oxygen, O2, on the reactant side. So you'll always see oxygen, O2, there on the reactant side of a combustion reaction. And on the product side will always be the same two products. There will be carbon dioxide, CO2, and water, H2O. So combustion, burning, always involves oxygen on the reactant side and carbon dioxide and water on the product side. So you can take a look at the picture there. The picture shows like an example of the combustion reaction. And you'll notice in there, you can see the two oxygens, the O2, on the reactant side, and you can also see the CO2 and the H2O on the product side. And that's a combustion reaction. All right, so I am going to ask you, I'm going to give you a chemical equation and ask you to tell me which type of chemical reaction is this? Which one of those five is this chemical reaction? So I have an example here. Let's have a look. It says N2 plus 3H2 react to form 2NH3. Which type of reaction is that? Well, I look at my 5 different types and I say, which one could it be? This really doesn't look like decomposition. Decomposition usually starts with just one thing on the reactant side, and here we have 2. It's clearly not combustion because we don't have oxygen, carbon dioxide, and water in it. That leaves me with synthesis, that leaves me with single replacement, and that leaves me with double replacement. Okay, which one could that be? Well, we have 2 things on the reactant side, and if you look at them, they're nitrogen and hydrogen, both of which are elements. Okay, so this is a reaction where we have 2 elements on the reactant side, and then over on the product side we have NH3, which is ammonia, which is a compound. So I have 2 elements on the reactant side, and I have a compound on the product side. This looks like 2 elements joining together to form a compound, which we call the synthesis reaction. So this reaction, this is a synthesis reaction. Let's have a look at one more example here. It says SnO4, that would be tin oxide, plus 4H2, that would be hydrogen. They react to form Sn, which is tin, plus 4H2O, which is water. Okay, well, what do we have on each side here? And let's think about which type of reaction is this. Is this a synthesis reaction? Do we have 2 things joining together to form one more complex thing? Doesn't really look like it because I have 2 things on the product side. Is this a decomposition reaction? Do I have one thing on the reactant side breaking up into different things on the product side? Doesn't really look like it. I have 2 different things on the reactant side. I can easily tell it's not combustion because there's no oxygen, there's no carbon dioxide. We've got water there, but we don't have oxygen or carbon dioxide in there. So that leaves me with the single replacement or the double replacement. And I ask myself, which one is this? The single replacement should have an element and a compound on both sides, and the double replacement should have 2 compounds on both sides. And I can look in there and I can see hydrogen, which is an element on the reactant side, and I can see tin, which is an element on the product side. So each side here we have an element, and the other thing is a compound on each side. So this here would be a single replacement reaction because we have an element and a compound on both sides. And if you look in the equation, you can tell that in the compound tin oxide, the hydrogen took the place of the tin, and then the tin is all by itself on the product side. So we have hydrogen replacing tin in a single replacement reaction. Okay, so there were 5 different types of reactions we talked about. We talked about the synthesis, the decomposition, the single replacement, the double replacement, and the combustion reactions. And we looked at a couple of examples of looking at a chemical equation and telling which type of reaction that is. So hopefully that helps us to be able to describe the different types of chemical reactions. Until next time, take it easy.